Okay, today I'm going to talk to you about states of matter. We're also going to have a look at state changes as well. So there are three states we need to know about. Three states are solids, liquids, and gases. Now, we're going to have a careful look at the arrangement of each of these. So first of all, let's start with solid. As you can see in solids, the particles are really closely packed together in a regular arrangement. For example, in these rows that we could see right here. Now, a misconception is that the particles in a solid do not move. They do. They all vibrate around a fixed position. So they do move, but they're not free to move wherever they want. They vibrate. Now, if I keep on adding thermal energy to this solid, eventually we will get a change of state called melting. So melting is when we change a solid to a liquid. When we melt on a substance, some of these strong forces of attraction are overcome and the particles are now free to move. As you can see, they're still tightly or pretty close together, but not quite as densely packed together as a solid. So this is what's happening in a liquid. The particles have more energy in their kinetic stores than particles in a solid. They can move freely and randomly in different directions. Now, if I was to add more energy here, heat these up further, eventually I would get a process called evaporation or evaporating. This is the process of turning a liquid to a gas. Again, now we're giving the particles more and more energy, because if I heat them up, the energy is transferred into particles' kinetic energy stores, making them move faster. So eventually they have enough energy to overcome their attraction, and then we have a gas forming. These particles move with a lot of energy randomly in any direction. There's virtually no forces acting between these particles at all. Now, we can go the other way instead. So instead of adding energy, we can remove energy, i.e. cool a substance down, in order to get a state change the other way. So the state change from a gas to a liquid is called condensing. We're making the particles have less energy, less kinetic energy, and eventually, due to having less movement, will start to form attractions between the different particles. So we now go from a gas to a liquid called condensing. The final state change of these, major state change, is this one here, from a liquid to a solid. And that process is called freezing. Again, we're removing even more energy. So these particles have less and less kinetic energy, so that after a while, strong attractions form between the different particles, holding them in these fixed positions. So we now have a solid. There's actually one final state change that I'm just going to show you. Some substances can go straight from a solid to a gas or a gas to a solid. And this change is called sublimating. So we just need to make a couple more notes about the differences between solids, liquids and gases. So we're going to have a look at the two extremes. So this end of the spectrum with solids and this end of the spectrum with gases. So in a solid, first of all, there are strong forces of attraction. This is what's holding the particles together in their fixed positions. Yes, they vibrate, but there's strong forces of attraction. Whereas this end, in a gas, there's almost no forces of attraction between the different particles. They're really spread out, and as a result there's very few forces whatsoever. We can look at the difference in density. So for most substances, solids have a higher density because the particles are more tightly packed together than liquids, than gases. So at this end we'd have the lower density. There are exceptions to this, but for most substances this is true. Finally, let's think about how much energy each one has in its kinetic store. The solids have the least energy in the kinetic store, so they have a low amount of energy in the kinetic store. So the particles do not move around freely, they vibrate around fixed positions. Whereas these gas particles here, they have lots of energy in the kinetic store. Now, the final thing that I want to talk about is state changes relating to mass. Now, despite density changing when we melt, evaporate, condense, freeze a substance, the mass never changes. We don't suddenly have particles lost or gained. So as a result, all of these state change results in the same mass of the substance. So during state changes, mass stays the same. So guys, hopefully that's gone through nicely, the difference between solids, liquids and gases, looking at state changes and what that means in terms of energy and density and mass. Thank you.